Hello guys, welcome to the another project. So today I'm going to show you how I built a complete data pipeline using Snowflake and dbt. So in this project we have created three layers. It's typically based on the Medellin architecture, which is bronze, silver and gold, to clean, transform and organize the data step by step. So we used dbt to build models, run tests and generate the documentation at the end. And by the end of the video you will see how dbt helps turning the raw data into clean, reliable, well structured and ready to use and for analysis data. This is the project architecture where we have the raw data sources in the first layer, which is the bronze layer. We have customers csv file, products and sales orders file. So we have sales order here, products and customers. So in customers we have customer name, first name, their last name, email id, nasik, that is city and country. And in the products we have product id, model name, brand, category, price. And sales order we have order id, customer id, product id, order date, quantity and the amount. This is basically the sales of bikes. So if you see Honda Shine, Honda Unicorn, Honda Hornet, Bajaj Pulsar, Pulsar NS200, Dominar. We are analyzing the data of bikes. We are analyzing the sales data of bikes in Nasik. So this is the first layer. Then we are injecting the data from the bronze layer to the silver layer, and we are cleaning up the data by removing the null values or removing the duplicates. And we are turning the data into clean data, and we are storing the data in the silver layer, which is the silver schema. We are creating new tables in the silver schema, which are customer clean, products clean and sales order clean. And from the silver layer the data is going to the gold layer, which is more analytics ready, more user friendly, and more transformation is done in the gold layer, which are also called as the business models. So in the gold layer, in the dbt we run the test, we build the models, generate the documentation and view the model lineages as well. So now we'll see how we uploaded these files in the Snowflake ingestion process and how we ingested the data into the tables in Snowflake. We created a database which is called as MotoMartETL. This is the schema we created in the databases. This is just to check if the database is working fine, and we can create schemas under that. We don't need to create schemas manually. The schemas will be directly created with the help of dbt in the further project. So create schema bronze, silver, gold. Bronze is used to store the raw data, unprocessed data loaded directly from csvs. Silver is used to store the cleaned, transformed data, validated data, and gold schema is used to store the aggregated fact and dimension, and one obt table is also stored in the gold layer. So now we use this database. We run this command called use database MotoMartETL, and we create a stage where we will store the raw csv files. So create or replace stage, we call that stage as bike sales stage, and we run this command to list all the stages which are present in the MotoMartETL database. So MotoMartETL database, we have a stage which is called as bike sales stage. Okay, this is not an external stage, this is internal stage. External stage also we can create with the help of Amazon S3 bucket, but we will have to provide the S3 link here. But we are not going to the AWS part now. We are creating an internal stage inside the Snowflake itself, so type would be internal here, and create these tables called customers, products and sales orders. Okay, so we will run these three commands here: create or replace table, and the table will be created, but still the table will be empty because there is no file ingested into the tables yet. So we'll load the files into the stage first. So to load the file in the stage, we'll have to go to the home first, then upload local files, then we will create a database here, MotoMartETL, and schema would be bronze, because in the bronze layer only we'll have to upload the files. So once we select bronze database, okay, this is optional. So we have created we have selected MotoMartETL and bronze schema. Browse the files, select all the 3 files, click on open. The files will be uploaded here, and just click on upload button at the below. Next, and then upload. So we have already done this part, so I'm not going to do it again. Once the files are uploaded on the stage layer, then we will copy the data from the stage layer to these tables separately: customer, products, and orders. So we'll use this copy into command, copy into this table from the stage. This is the file name we are going to copy, customers.csv in the customer table. File format would be CSV. Field optional enclosed by the double quote, and header we have to skip the header because we already created these headers here. So we'll run this command and then do the select star on the customer. So we have all the data here in the customer table. Similarly, we'll run the copy to command for products and orders. So we are doing select star on products here. We have the data, and in the orders, I'll show you one thing. So in the orders, I'll just open this file. I want to open this file in the where is the source data? Orders. I want to open this file in the notepad++. Would be able to show you how the date format looks like in the raw data. So date here is in the form of ddmmyy, but Snowflake recognize the date format in a default way as yymmdd. After injecting the raw data in the Snowflake table, it would show an error, date format error. So to resolve this error, we are doing a thing here which is called as this date format thing. So this line is important because in our raw file the date format is ddmmyy, we just saw, but Snowflake default date format is yymmdd. So we are turning this yymmdd default format of Snowflake to ddmmyy, which is our raw data format. So once we run this command, we would have all the data in the sales order table. So select star on sales order, we have yymmdd. Bronze layer is completed. Bronze layer is just nothing but copying the raw data in our bronze layer tables, which is customer, products, and sales order. So we have completed till step 3. Now the step 4 is setting up a dbt project and create a virtual environment and install dbt Snowflake and initialize the dbt project in the VS Code. So in the VS Code, we have already initialized a dbt project here, and we have installed dbt Snowflake as well by running command of dbt install dbt Snowflake. And to initialize a project, we use dbt init and a project name MotoMartETL dbt. So this part is already done. Now we have to create a virtual environment. So to create a virtual environment, we have to provide a command. Let me just show you. Command to create a virtual environment in Python. So create a virtual environment in Python, we have a built-in module called env. So to create a virtual environment in Python, we have a command of this python -m virtual environment and a virtual environment name in the terminal, and replace this with the name you want to give to the virtual environment folder, like my virtual environment or .env. So in our case, we have provided a name of venv. This is the virtual environment name, and once the virtual environment is created, we have to run a command of .venv/scripts/activate to activate the virtual environment in our VS Code project, to activate the virtual environment. Now the next step of our project is configure the connection, edit the profiles.yaml file with the Snowflake account, database, warehouse, and schema details. So the profiles.yaml, I'll just show you where it is. So it would be under C, users, the username, and .dbt. So this is the profiles.yaml. If I open this file in Notepad++, I'll show you how it looks. So this is the another project of mine, and this is the one we are looking into, MotoMartETL. So outputs, so it would be in the dev environment, type is Snowflake, this is my account name, this is my username, password, role, warehouse, database, schema, and threads are 4, and client session keep active is false. This is my password, but don't worry, once this video is live, this password will also be gone. This is the profiles.yaml. This is our project setup file. This part is also done. will move towards building the bronze models or create a dbt models that references the bronze tables. We have not created any bronze schema here because bronze schema will create manually in the Snowflake. So bronze, I'll just show you the databases. I'll refresh it once. MotoMartETL. So this is bronze. We have a stage in this bronze layer. This stage we have created this into bronze layer only. Sorry, where is that stage? Okay, this one. These tables we created manually here, and we have created it under the bronze schema only. These tables have the raw data, and the raw data injecting in these tables is nothing but a bronze layer in our dbt project. If you see this project architecture, so raw data sources is nothing but a bronze layer ingestion into these three tables. How the dbt would know that we have these three tables present in the Snowflake? So we have to provide a schema.yaml file inside the models, and it would point towards the source files. So this is version. You can create any kind of version here. I am giving it as 2. We are providing the schema.yaml sources name as bronze. So I'm creating a bronze here. Database we are using as MotoMartETL. Schema we are using bronze layer from the dbt schema, and we are referencing these three tables as a source inside this project for silver and gold layer from Snowflake. So these are the three tables we are referring to: customer, products, and sales orders. So that dbt would know, okay, these are the three tables I have to refer inside the Snowflake with the help of this source ingestion. So next step is building the silver models, cleaning and standardize the data, like removing the duplicate values or fixing the casting or validating the emails or creating a new columns. That is also part of silver schema. In the models folder, we have created one silver folder which consists of three files: customer clean, product clean, and sales order clean. In these files, I'll open all of them side by side. You will know how it looks. So in the customer clean, we are initializing a CTE here, which is called as dedupe, where we are removing the duplicate values and selecting only the necessary columns, or transforming the columns into a specific way from the source, which is our bronze customer file. I'll just tell you this thing one by one. So we are initializing a configure, and we are materializing it as a table. So we have three types of configs here. Materialization here we have ephemeral, incremental, table, and we have 4 types, and we are storing these results of this table in this schema silver. That's why realized as table and store it in the silver schema. So this CTE is selecting columns called as a customer ID, first name, last name. First name is basically we are using this in inside the init cap function. So this function capitalizes the first letter of each word in the string. Similarly, we are doing it for the last name. Now here we have built a function. Function is nothing but a macro in this dbt. Save concat. We are running a function, and we are providing a parameters here, 2 parameters basically, first name and last name, and we are concatenating this first name and last name, and we are saying a new derived column as full name. So this line uses a save concat macro to concatenate first name and last name with a space in between. So we don't have a space here. We have not said that we have to provide a space in between first name and last name, but where it should be written, it should be written under the save concat function. This save concat function is present in a macro folder. It is basically a macro, so it's written in the macro folder. This is the one. So what this macro says, we have initialized a macro here called as save concat. It takes a column 1, column 2, 2 columns, and a separator which is space, and this macro concatenates 2 columns if either column 1 is null, keeps without breaking. So concatenate ws is a function name which takes separator, which is this space, as a parameter, and column 1 and column 2, and we are ending a macro here. This macro is used here, and we can use it in any kind of model here. So to skip the repetitive task or reiterating this line in every other macro, we are building a function, and we are just calling the function in every other every other model to do the code reusability. And now we are validating email column, and we are saying that it should be the lowercase. If in the source file we have email name with the uppercase, then capital letters to the small letters. So lower function converts the string into lowercase. We are taking city country year from this file, from this file, okay. And we are saying that where email should not be null, and we are selecting all these columns, which is select star from this city dedupe. If I run a compile code here, how it would look like, I want to see. Okay, see, this is the compiled code here. Similarly, we have done for products clean. We have a configuration as materialized as table, and it is present under the silver schema. We are selecting distinct product IDs, trim the model name. So trim function will remove any leading or trailing white spaces for the product name. Sorry, not the product name, but this should be the model name. Init capitalizes the first letter of each word in the string. For the category column, we are typecasting a price column here, and we are saying if the price is in the decimal format, then we would like to go for 2-digit decimal only. So cast function provides the price into decimal with 10 digits and 2 decimal places. From, we are referencing this from the source model products file, where product ID is not null and price should be greater than 1 lakh. So if the bike price is greater than 1 lakh, then only it would be stored under the product clean table. Now we'll go to the sales orders clean. So we are doing the same thing here. We are taking the necessary columns here: order ID, customer ID, product ID, quantity, and we are casting a order date here. So order date should be always a date. It should be not any other value apart from date. We are taking these values from a bronze schema, from sales order, where quantity is greater than 0. Quantity, if it is 0 or less than 0, it cannot be less than 0. If it is less than 0, then it's a invalid row. It should be getting wiped off from this condition. And customer ID should be not null, product ID should be not null, and amount should be greater than 1 lakh. With the columns affecting with this filtering out condition, it will be removed out. Okay, now so after running these silver models by using a command of dbt run -silver, or we can also run all these models one by one, we would see silver schema initialized here and all the 3 cleaned tables here in the Snowflake. So if I give a command of select star on all the 3 tables, we'll have the cleaned up data. See, we have full name column here, we have email IDs in the small letters used in cap function, right? So it capitalizes all the letters for first name and last name as well. For the products clean, we have cleaned data. We have removed all the products which are less than 1 lakh, so all the values should be greater than 1 lakh here. Sales order clean did the same thing here, right? Order ID, customer ID, product ID, country, and order date. So order date is not null here. If it was not null in the bronze layer, then it would be removed after getting stored in the silver layer. This is how we build our silver layer. Now it's turn to build a gold model here. But before going towards the gold layer, I would like to show you one thing I just forgot to explain you at the starting of this project. This dbt project.yaml file is an important YAML file in this project. It consists of information stored for our dbt project. So name of the dbt project is this one. This name should be similar to the name in the profile.yaml we just saw. The version is 1, so profile.yaml, this is the file, this is the name which is present in the profile.yaml file as well. It should match. If it doesn't match, then it would that the file name is mismatch, or this file or this project doesn't appear to be in the profile.yaml. We have all the paths here. This is pre-written, we don't have to write this again. This is also pre-written, and we have to initialize or materialized our models in a specific way. Like I did the bronze layer materialization as view. For silver layer, the materialization for all the models would be table. That means the data will be stored in the form of table here for silver and gold. But for the bronze, the data will be stored in the form of view. Okay, this is the dbt project.yaml. Now the gold layer is consist of 4 files: dim customer, dim products, fact sales, and sales opt. I want to go first for let's go for the opt. We have these 3 files stored in the silver layer, and these 3 files created 3 tables in the snowflake as well in the silver layer. Okay, customer clean, product clean, and sales order clean in the silver layer, and this is in the form of table. Okay, so now we would materialize this sales opt table. Opt is nothing but one big table. So we are selecting all the columns which are present in these 3 files in this one table, or in this one file, or in one table as well. You can say this as a table schema. It would be present under the golden schema. We are selecting this 4 columns from, I think, customer table, these 3 4 columns from the product table, and these from the sales table. Okay, these are nothing but the columns present under these clean tables. We are joining all these 3 tables on the basis of this customer ID and product ID, and we are selecting all the columns which are present under these tables, and we are giving the name as sales opt tables. We have all the data under one big table. So now we have to split this one big table into fact and dimension. We are basically building a star schema here. I would like to go for the dim first. We have customer, so whatever columns present in the opt table is related to the customer, we will move it to the dim customer. So see, we are materializing it as table only, storing it in the golden layer, and we are selecting customer ID, full name, email, city, and country. These 5 columns we are selecting from opt table, which is sales opt. See, we are referencing another model into this model, and we are running this under dim customer table. Similarly, we are doing for dim products. OPT should be here. We are selecting product ID, model name, and category. Okay, these 3 columns here from OPT table, and we are storing it under the golden layer. Materialization is table, and the table name it would create in the snowflake. It would be named as dim underscore products. Now the same thing we are doing for fact. See, we are selecting all the columns which have numerical values. So order id is a numerical value, order date is numeric, customer id, product id, price, quantity, and total amount from all these columns are numerical values. That's why we are storing it under the fact table, because fact stores only the numerical values, quantity values, and dimension table stores the information related stuff, that is name, email id, or a full name, country, city, location. That kind of information is present under dimension tables. So now we have splitted the one big table into opt, one big table, that is opt table, into fact and dimension. And once we run this sequels, that means if we provide a command in the terminal called as dbt run, it would create a schema, golden schema, inside snowflake, and all these 4 tables will be created here. I have also written some tests here to validate the data according to the business need. For example, for the model called customer clean, the description I have provided as cleaned customer data. The columns which I want to write the test on is customer id, and the test would be unique and not null. So basically it says that the customer ID column should be unique and not null. Email ID column should be not null. Similarly, for the another model called as product clean, I said that the product ID column should be unique and not null. Price should be not null. Similarly, we have all the test written on all the columns. So this column says dim product says the product ID should be unique and not null. Dim customer says the customer ID should be unique and not null. That way. Next topic is run dbt, execute dbt run, build the models and dbt test and validate them. So we have already run all the dbt models here, validated them on the basis of the business need. We have also validated all the columns in Snowflake, how it looks, how it is interlinked to each other, what's the relation type on all the models, what's the lineages. So I'll just walk you through one of the macro. So this macro is called as a schema generate name macro. This is a custom macro. It takes as a custom schema name as a parameter and a node. It overrides the default behavior of the use schema directly, and it only takes the custom schema name. So custom schema name is basically, I'll just open one of the model here, anything. It takes as a custom schema name. Okay, so the schema name is gold and silver here. So this schema, this macro will generate a schema called as a gold or silver only in Snowflake. By default, custom schema would be bronze, 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 silver, and bronze, gold. But after writing this macro, we will get the custom schema name as bronze, silver, and gold. The bronze underscore would be removed from this by writing this macro. I also want to let you know that dbt provides automating documentation, and we can create a documentation localhost website with the help of two commands. First is dbt docs generate. This command will compile all the files. If the files have any errors, it will check the relationship, it will check the lineage of all the files, models, macros present in this. It is scanning bronze layer. It found the 7 models inside the models folder. It is building a catalog, and the catalog is written in the target location under the catalog.json. Now it has generated a documentation, but now to serve it to us, we have to write a command called dbt serve. This will create a localhost link and provide it to us. Now it will be redirected to the Chrome. Say this is the localhost link. We have been redirected to the localhost website in the Chrome browser, and see, this is such a beautiful website. It created it for us. So it also says more information, what is dbt viewpoints, installation, dbt join the community question answer, welcome, navigation, project tab, database tab, graph exploration, lineages, model, select, exclude. Whatever information you need regarding dbt is present here, but we want only the information, the table structure which our project has. So this is the project. We have sources called as customers, product, and sales order. We'll go one by one. Customer, in the details we have a customer table. It is in the package or a database. We can call it as a MotoMartETL dbt. Forced contract is not enforced, bronze. It is stored in the bronze. Source schema, you can also call it a schema. It is approximately the size, 3 KB of size. The modified last step, row count is 50, and this source is not currently documented. That means we have not written in the description for this customer, product, or sales order. So it is saying that it is not currently documented. These are the columns present in the sales order. These are the columns present in the custom products. These are the columns present in the customers. This is a SQL file for products. This is simple SQL. This is orders. This is SQL for the orders. Now we'll see macros. See, these are the two macros which we created. It takes the column 1 as a parameter, column 2 as parameter, and the separator. See, this is the macro we wrote in dbt and directly provided us a documentation page or a website which our project has. See, we have two layers here, gold and silver. Bronze is already present in the source location. We have all the columns. So see, this is written in Jinja SQL. This SQL is a Jinja SQL. And if we see the compiled version of it, this is the compiled one. See, select distinct customer ID, full name, email, city, country. So select distinct customer ID, full name, email, country. From, we are referring a model here, which is called as sales OBT. But sales OPT is a table only, right? Sales OPT is a model only. In this way, we have all the models here, all the folder structure, project structure, and this is the lineage graph. See, if I open this, so these are our bronze layer, bronze tables, bronze customer, bronze product, bronze sales order. It is directly linked to the customer clean, product link, and products link and sales orders links, because we have written a relationship like in that way that this customer clean will directly be referred from the bronze customers. Customer clean, product clean, customer sales order clean is a silver layer. So this silver layer is now compiled into a one obt table. From sales obt we have directly linked it with the help of customer dim customer and dim customer. Not just dim customer, basically we have linked it with fact, dim product, and dim customer. All these three: dim customer, product, fact, and opt. But I don't know why it's not showing here, or if it's not refreshed correctly. I'm not sure. Let me check and we'll get back to your update in the GitHub page as well. Okay. Yeah. So guys, that's it for this video. We have built a complete dbt project on Snowflake, from the raw data in the bronze layer to the clean data in the silver layer and business ready models in the gold layer. You saw how the dbt helps us to automate data transformation, dbt testing, documentation, all in one workflow. So I'm uploading this project in the GitHub now, and you would be able to see there, access all the files there. If you find this video helpful, just like it. You can also check my GitHub repository. Thanks for watching. See you in next one.